bold ideas. We are excited to witness how you transform constraint into opportunities. Let's innovatively, boldly, and lead at the edge. To formally begin today's event, I invite Sanjay to deliver the welcome address. Sanjay, the platform is yours.
Good afternoon, everyone. It gives immense pleasure to welcome to all. Edge under consent, the Edge Ideathon competition proudly organized by Edzen, the Edge AI Club. I extremely respectful welcome to our Academy Director and Club Convener, Dr. S. Palanimurugan sir, our Head of the Department, Dr. J. Amuda ma'am, our AHOD and Club Coordinator, Mrs. Agilandeshwari ma'am, our club mentor, R. Gopinath sir, and all our respected faculty members continuously support and guide us our driving force behind an initiative. A special welcome to our esteemed jury members joining to evaluate and guide our participant today. And most importantly, and heartfelt welcome to all the participants, your courage. The innovative and constant truly reflect the split of AGAI. Thinking smart, designing efficiently, and solving real-time problem. These ideas are not just a competition, but a platform turned into limitation and innovation and ideas into impact. Wishing all the very best. Let's make today's celebration of creative and intelligent problem solving. Thank you.
Thank you, Sanjay, for the motivating welcome. Now let's move to an important part of our program, introducing the expert who will evaluate and guide today's competition. I invite Fahumita Afros to introduce our respected jury member. Please take it forward.
Everyone. Now it's my privilege to introduce our estimated jury member for today's competition. We are honored to have Mr. V. Manikanda Prabhu sir, ME, Assistant Professor, Department of Artificial Intelligence and Data Science, and also he is the guide of the AGI academic project and has consistently mentored the students in building practical and real-world AI solutions. With a strong academic foundation and valuable industry experience, he brings a balanced perspective of both theoretical knowledge and practical implementation. This makes him the ideal evaluator for an ideathon under constraint. We are truly privileged to have him guide and assess our participants today. We warmly welcome you, sir.
Thank you, Fahumita. Now come the most existing segment of today's Ideathon presentation. Each team will have 7 minutes to present, followed by 3 minutes of the jury interaction. Let's begin the journey of innovation under constraint. First team, the Edge Flow. Next, stepping confidently into the challenge space, Team Edge Flow, Mahadi and Preeti. We are ready to explore your approach. Please begin. Can I share the screen?
Yes.
Please go ahead.
Good evening, sir. Good evening, one and all present here. I am Mahadi and my team member Preeti from CS-based department. Our topic is smart traffic signal optimization using Edge AI. In this topic, we have implemented the AI YOLO V6 and V8 for detecting the signal better. It cannot be included any cloud or internet services. Move to next slide. In this problem statement, urban interactions face heavy traffic, like traffic signals today follow a fixed time, even when the traffic is low or high. So that why does it matter means increased waiting time. People waste time standing at signals and fuel wastage. Fuel wastage means vehicles burn petrols while waiting. Then higher carbon emissions, more population is in traffic means it releases more pollutions in air, so it affect the air pollutions and emergency vehicle delays. In emergency vehicle, ambulance and fire detects can be weighted in more traffic. Next slide. In this main challenges, real-time vehicle detection and counting. In this system must count vehicles constantly. Example, camera detects 20 bikes, then 5 cars are waiting like that. And then a dynamic signal timing without cloud support. Signals should change automatically without internet by connecting the Ethernet cable like that. Then fully offline operation with a local synchronization. Nearby signals must communicate local servers like a microcomputer like that. Next slide. Our proposed solution was Edge AI based adaptive traffic signal control. AI runs inside a local device near signals. Example, a small computer near signal analyze camera videos like that. How it solves the problem means detect and count vehicle using cameras like SIMs, cars, bikes, buses like that, and then calculate congestion level checks how many devices can be in the lane has more vehicles like that. Then adjust green signal durations. For example, more traffic means longer green light can be given, and lesser traffic means the green light will be given to lesser time like that. And then synchronize with nearby signals via local network. For example, if one road is crowded, it gives more green light for that road is given. Next slide. In this, our key features are real-time vehicle detection. It can be analyzed the instant vehicle, how much vehicles can be in waiting. Then fully offline processing. In this, no internet or cloud storage is needed for this process. Then local signal coordination. In this, signal can be cooperated and connected to each devices. And then emergency vehicle prioritization. Like that, ambulance gets green first because of the emergency alert. Move to next slide. In this architecture diagram, the camera can watch the road and captures the video, and then edge device. In this edge device, video from the camera can be sent into the edge device. In this, the video can be processed and detect vehicle, how much vehicles like cars, buses, how much can be it in using the AI like YOLO. And then it moves to the traffic controller. The process of information in the edge device is given to the traffic controller. It can be decided which signal should turn on green and which signal go to red and how long it is. And then it can given to the signal of signal lights. In this, it can decide signal light change based on the controller decision. In this, main components are input. And then we give an input is CCTV cameras or vehicle sensors like that. In the CCTV camera, for example, it collects the traffic data like roadside surveillance cameras like that. And then processing of edge devices, Jetson. In this, we can process the camera videos. We can use Jetson. And then AI-based vehicle decision model. In this, YOLO can be used because of YOLO. You only look once like that. It can be detect the objects like how much vehicles like that. And then output is optimize the signal timing, how much time can be given in green lights or red light like that. Move to next slide. AI model selection. The model is YOLO V5 and YOLO V8. Because of this, for example, in rainy season means the camera cannot be detected clearly. For this YOLO V5 and YOLO V8, we can train the data when more data can be trained so that it can detect during the rainy season also how much vehicles can be in there. Like that can be predicted. Why we use it means it is a fast time detections and accurate counting like that. And then model details, the size can be to 10 to 15 MP, and the input is a video frames. It can detect the videos of how much vehicles can be wait in the queue. Then output. In this output, by the video frames, it can give the output of how much vehicle can be in waiting, and this can be detected by the rectangular box of uh, counting the vehicles. The next slide will be taken by Preeti.
Optimization techniques. Since edge devices have limited memory and power, optimize the model applied quantitation, reduce model size by converting data to smaller precision. The model tuning removes unnecessary neurons from the network. It reduce resolution, lower image resolution, improves processing speed. This makes the system lightweight and efficient. Things. The edge AI on computation. The edge AI no focus. In the real-time adaptation, dynamic for dynamic signal timing, density is calculated every few seconds. In the network limitation, a fully offline system, the system work completely offline. The local synchronization. Nearby signals communicate through LAN network only. So the system is secure, independent, and reliable. To the next slide, the resource usage. Our system is designed to be low cost and practical. CPU usage around 60% and the memory 2 to 4 GB, the storage less than 500 MB, the power consumption only 5 to 10 watts. So it can be easily deployed using affordable hardware. In the next slide, what makes us unique? Our project has three main innovations. Fully offline intelligent control. It is no cloud or internet record. Local signals nets. Second one is local signal coordination. It is adjacent intersection share traffic information. Third one is emergency vehicle priority. It ambulance is detected, signal immediately turns green for the tank. Extra features the traffic data logging and night detection computation plan. Week 1 to 2 collect the data and train the AI model. The week 3 to 4 is deploy the model. In the challenges of this project, the challenges and poor lighting. The solution of this project is in the conclusion is we successfully developed a smart traffic signal system using Edge AI that dynamically adjusts signals timing and reduce congestions, saves fuel and to reduce pollution, improves emergency response time. The system is practical, scalable, and future ready for smart cities. Thank you.
Okay, good afternoon.
Good afternoon, sir.
Okay, so what is your project requirements?
Our project requirements is YOLO AI, it is a AI model, and then camera, and then traffic controller, and then signal lights to detect, sir.
What is the device you are going to use?
AI model, sir.
So you know that I think Jetson Nano or Raspberry Pi, like the way which device you are going to use for a detection for YOLO. For what is the YOLO actually?
It is one of the AI tools, sir. It is used to detect the objects, how many cars, bikes like that can be weight.
Okay,
In this, we use object detection algorithm and rule-based algorithm, sir.
okay. Can you please tell AJ in one sentence?
I can't understand the question, sir.
Actually, I want to know that AJ. What is AJ?
Um, Edge means
I want to know that
using
we are using. Okay, we are
local
doing the
device
project in
directly
Edge.
connect used to
Yes. Actually, what I want to know is
uh,
Edge AI is why important here. So without cloud or any interaction, how we are going to do the project? Without internet connection, how we are going to implement these things in a traffic itself? I got it.
without cloud and internet, we can use the cameras to detect the vehicles, and then using Ethernet cables. These cables, because of the near computers, we can connect this cable into the computer. In this, we can use a traffic controller, and then it can detect the YOLO V5, V6, and V8 to detect how much uh, vehicles are waiting, and then it give the signals immediately, sir. For edge AI means it is directly on local device sending data without sending data to cloud or internet like that, sir.
Okay, how you are going to connect the control rooms? Actually, what are the signals we are connected from your station to other station? How you are going to uh, connect or communicate?
Uh, in
Because
camera, we can use Ethernet cable to connect, and then once you connect means in the AI can be implemented in the microcomputer like that. This can be processed and given to the cable, given to the output to cable. It can reflected in a traffic signal, sir.
okay, can I get the things? What are the things currently going on in our traffic signal systems?
It
What
is
are the implementation we are doing here?
existing things, sir.
Sorry.
Uh,
Yeah, I want to know the existing system and your why your project is needed.
in existing systems, for example, in four blocks of road, each has one of the road has a 10 vehicle and another one 100, another one 5 means it gives same time to all the roads, sir. For example, a red signal means it gives all the roads for 5 minutes means all for 5 minutes. It is a time flow. Mm, Time can be increased for many peoples and emergency vehicles. Our solution is it can be detected through cameras and the using of AI. It can predict how much vehicles that can be in queue. Like that, it predict and give the signals according to the vehicles waiting, sir.
So you are going to implement the things so based on the current capturing, right? So
Yes, sir.
it will take some time, right? Whenever you have to capture, then you have to process. Based on that, you have to
Yeah,
give the signal, right?
it is frequently capturing the flow of data, sir.
Okay. So what is YOLO actually?
YOLO means you only look once. It is used to detect the objects or vehicles like that, sir.
Yes. So the meaning is in the same YOLO. Okay. Once in a time, you can take and capture it.
Once, yes, sir.
Yeah. Once you look, it is actually take
Action.
capture directly, and we can use it immediately to the
Uh,
to the equipment, and you can control it. Okay.
yes, sir.
Uh, okay. What is your future expansion? See, actually, in rainy days or if there is no light, means what we are going to do in the future.
In this, because of we choose YOLO V6 and V8, sir, this can be detected and can be data can be pre-processed by giving various type of data and the training the AI model. How you can predict it during the rainy days, during night, and the climate can be changes so that we can use this, sir.
So I want to know that in a low light, how you are going to capture, because that we can get the proper data from that capturing and all.
By giving the data, sir, by labeled data and unlabeled data, we can give various data to process this AI. During the light cannot be in, more means how the vehicles pictures like that, sir.
See, for
Train
that
the AI model.
you have to use a high definition camera for that, right?
Yes, sir.
So your project should be in a, okay. Okay, thank you. Thanks for it.
Okay, sir.
Okay, we are moving to the next. We can move to the next.
Thank you, the team of
Okay,
Edge
thank you.
Flow. for insightful and well structured solution. We truly appreciate the effort and clarity you have been demonstrated in design within your assigned constraint. Thank you, sir, for your guidance and truly add value to this learning experience. Our next team is move forward. We welcome Team Hack Her Mind. Keetana, we are excited to hear your innovative perspective. Please begin.
Hello everyone, can you please share the screen?
Please go ahead.
Thank you, sir.
1 minute, please. Screen is visible.
Yes, Dharani, thank you.
Yes.
Okay. Hello everyone, I'm Keetana Raghupati. Today I'm presenting my idea title is Smart Bin, an Edge AI powered biomedical waste segregation system. This idea is designed specifically for smaller clinics and hospitals, which is represented in the rural areas where intelligent waste segregation is currently missing. Next slide, please. So here is the problem statement. First of all, biomedical waste segregation is most small in healthcare facilities and it is still manual. Healthcare workers have to handle infectious hazardous waste like syringes and used syringes, gloves and mask every day. They must decide quickly which bin belongs to which waste and like that. So it will create a fatal issue that will risk the person's life who are handling the wastes. So this exposes them to infection and increases stress and often leads to improper segregation. So the problem is not lack of issues, and but the problem is lack of real-time intelligence at the point of disposal itself. So that is why we are choosing the idea. Large hospitals may afford automated systems, but the smaller clinics cannot afford them. So they face three major limitations such as high cost, unreliable internet, and data privacy concern due to hospitals and clinics contain sensitive data such as patient healthcare details. They must be kept private, right? So at the time, waste segregation cannot wait for cloud decision and the time latency taken by the processor and the internet. So it must happen instantly, quickly, exactly where the waste is actually generated. So the key challenges we faced is from my analysis. The key challenges are there is a direct human contact with hazardous waste and the absence of real time on site intelligence, and also the cloud based solution being expensive and they are being unreliable. So, what if the bin itself can make the decision? So, here comes the technology edge AI. So, next slide, please. So here is the proposed solution. So I propose a solution called Edge Smart Bin. It is a conceptual edge native AI system where the intelligence is directly embedded into the bin itself. The system automatically identifies the type of biomedical waste and route it into the correct compartment or the dustbin without the human interaction or contact and without cloud and internet dependency itself. So it will make the system affordable, fast, and privacy, and also it is helpful to reduce the risk of people who are in the job of cleaning the medical wastes. So how the system actually works is when the waste is placed or dropped into the bin, an embedded camera captures the image. A lightweight AI model we are using is a lightweight CNN, just like MobileNet, running locally on the device, and it will analyze the image. So based on the image, it will the model will categorize the waste into which type of waste is it. And the mechanical routing, like an actuator, it will help to directly put the waste into the appropriate bin. So all the decision making happens on the edge itself, not in the cloud or not in other places. So the key features proposed in the system are real-time AI interface, touch-free automated segregation without human interaction, and then offline operation with complete data privacy. So this will make it suitable and sustainable even for rural and road resource clinics itself. So next slide, please. Thank you. So this is the proposed system architecture. So I designed the architecture in three conceptual layers. First is the perception layer, which the camera captures the waste images, and then it will move on to the edge intelligence layer. So in the edge intelligence layer, the AI model performs classification locally. The learning we are using is supervised learning, so it will, based on the data set, it will predict the what type of waste it is, and it will perform the classification locally on the device itself. So third, it will move on to the actuator layer, which is the mechanical system. It will route the waste into the correct type of bin. So this layer design ensures modularity and feature scalability also. Next slide, please. Okay. AI models selection. So for the AI component, we are using lightweight CNN, which is inspired by mobile net architecture. This model is suitable because it has small memory footprint, because the system cannot handle so much memory if we use a complex machine learning model. So we are using lightweight CNN, and it runs fast on the edge of hardware itself, and then it will balance its accuracy, and the model output the waste category along with the confidence score. So next slide, please. So edge optimization strategy is, since this is an edge system, optimization is completely essential. So what here it is proposed is quantization. We are using quantization to reduce the memory usage by rounding off the floating points, and then pruning to remove the redundant layers and unnecessary features. And then we are using event trigger interfaces to save power. Whenever the waste is dropped, only the machine is going to be in on mode. Otherwise it will be off mode. So deployment is planned using edge friendly frameworks like TensorFlow Lite, Micro, like that. And then next slide, please. So, these are the constraints which is given by the club to for this competition itself. So, this slide shows the our idea meets all the given constraints. We keep our cost under 10,000 rupees using low cost edge hardware, and AJA is mandatory also. So, all the inference happens on the device itself. All the processing is happening on the device itself. So, and then the system also work in real time, which is under 300 milliseconds, which is given in the constraint. And then it is completely offline, and it has no relationship within the cloud system, so zero cloud dependency also. And since segregation is automated, human contact with the waste is reduced. Next slide, please. So resource usage here, we show estimated usage. We use a lightweight CNN, so CPU usage is moderate, and also memory and storage are kept low using static allocation, and as I said before, model quantization. And power consumption is around 4 to 5 watts because of even triggered actions. And overall, the system is very efficient and suitable for edge devices. Next slide, please. So how this idea is unique means, it is age first by design. Decision making happens exactly where the waste is generated and dropped. So we also propose a detection of unknown or mixed wastes. When if the waste dropped here is unknown, it will directly route to the unknown dustbin. And manual override for safety and scalability to more waste categories. These are the future aspects. And then next slide, please. So this is the proposed timeline. So we are the for the week one we are expecting for the data preparation, which is the most important step for supervised learning, and then week two for model training and optimization, and then week three for hardware integration and actuator control, week four testing, validation, and demonstration. So all the components are if all the components are ready means we can practically make the idea possible. And the next slide, please. And then for conclusion, this AJA solution it aims to improve safety among people and the workers and safety efficiency in the biomedical waste management. So it reduces human exposure, human contact, and it also removes unreliable internet and cloud dependency. So it can be used in small clinics with intelligent automation. So this is the core. It contains the core intelligence of the system in the device itself. Next slide. So thank you for your time and attention. I would happy to take any questions.
Yeah. Good afternoon.
Good afternoon, sir.
Okay, where you are going to apply these things?
So where we are
Practical.
going to apply this thing is the clinics and hospitals present in the rural areas, because in cities the hospitals have automated systems in there, and they have cloud system integrated with the devices too, so they can afford
But we
high
have,
cost. Sir.
but we have everywhere internet, right? We have everywhere cloud. Even though, right? Why we are going for a without internet?
So why we are going for without internet is so internet is unreliable, so we cannot rely on internet or depend on internet anytime. So what if some problem occurs in the connection or the network, it will causes latency. So segregation will be delayed, so it will definitely move on to the manual removal of the wastage, so it will cause a risk of human life, sir. So in that cases we can use AGI, sir.
Okay, how you are going to implement? What are the things you need to implement in one hospital? Actually, you have one hospital. Okay,
Okay,
there
sir.
was a there was a 10 departments, different departments. Okay, each have two or three bins. How you are going to implement? How many requirements you have?
So the main thing is the processor, sir, which is the brain. So I'm planning to use Raspberry Pi 4 or Raspberry Pi 3, which supports CNN architecture very well. And then the other thing is a camera which is connected with which can be connected to the Raspberry Pi camera module. So it can be used to process the data, and for the AGI development we can use Impulse Studio like this for integrating the device into the AGI model. And also, if possible, we can scale it to using sensors, and more devices can be attached to it, sir, in the future. But with the constraint of 10,000 rupees, we can only do this.
Actually, what is the cost of the Raspberry Pi and the cameras?
Yes, sir, it will cost more actually.
But you have the cost you are mentioning is 8,000, right? It is
Yes,
possible within 8,000 to implement.
the whole project itself cannot be implemented within 10,000 rupees, because the Raspberry Pi itself cost 8,000 rupees, something like that. Along with the camera, it definitely will cost more. So it is
How we are
cannot
going
be.
to simplify? How can we
Um,
simplify it for a small hospital?
So we can just connect it with the camera, and with this minimized system, sir. We can just use CNN. The model we are using lightweight model also. So when integrated, we can when scalable to a limited segregation. So limited space itself, we can minimize the system is the only solution for this problem, sir.
Okay, what are the four types of waste segregation? The medical. What are the colors we are using for the bins?
Sorry, sir.
So what are all the bin colors? What are all the bin colors based on the waste? Yeah, you know
Um,
that.
For segregations, sir.
For segregation. Yes.
So
We are
green,
we
blue.
actually we are using different types of colors for a different types of waste, right? So have you know that which type of waste, which type of bins we are going to use? Then how you are going to model that, and how you are going to train the AI based on.
So we the existing dustbin colors you are asking is red dustbin can be used for hazardous chemical wastes, and then for dry wastes we can use blue, and then for degradable wastes we can use green dustbins. And for sanitary like gloves and then cotton pads like that we can use yellow dustbins. And then and the about model training you asked before, the data set must be very precise to avoid any unnecessary errors. So the data collection process is the most important one for supervised learning. So that is how I'm going to train the model with the proper data set of proper images.
Okay. Okay. Thank you.
Thank you, sir.
We can move to the next. Thank you.
Thank you, Keetana. Our next team is now entering with the now entering with Spark, and team name is Twin Star. Swati and Anjita, let's see how you engaging your solution. Go ahead. Swati, are you there?
Can you share my slides?
Yeah. Please go ahead. Please go ahead.
Good evening,
Screen is
everyone.
visible.
Yes, visible. Shall I start, sir?
Yeah. Yeah. Please go ahead.
Good evening, everyone. I'm Shwati, coming from the Department of Artificial Intelligence and Data Science. Here, our project is edge-based smart traffic signal optimization system. Next slide. Here, our problem statement is at many urban intersections, traffic signals operate using fixed timing only. This means the signal duration does not change based on actual traffic density. As a result, even if one road has very less traffic and another road is heavily congested, both receive equal signal time. This leads to fuel wastage, increased air pollutions, delays in emergency response, and driver frustrations. In this, we face main challenges like vehicle detections, accurate classification, low latency decision making under 1 second, and ensuring the system works without cloud dependency. Move to next slide. Here, our proposed solution is Edge AI-powered adaptive traffic control system. Our system captures live video from CCTV cameras and processes it locally using an edge device. And how does it solve the problem? The AI model detects and counts the vehicles in real time. Based on the calculated congestion level, the signal timing is dynamically adjusted. The system also supports emergency vehicle prioritization and operates completely on edge without requiring internet connectivity. For example, if lane A has 40 vehicles and lane B has only 5 vehicles, our traditional system focus on only the fixed timing, but our system automatically gives more green time to lane A, which has more vehicles, and less time to lane B, which has minimum vehicles. If any emergency or an ambulance is detected, the system immediately gives green signal to that line. For move to next slide. Here, the system architecture. System consists of three main components. First is the input layer, which includes CCTV or IP cameras that captures live traffic video. Secondary is the processing layer, where an edge device such as Raspberry Pi or Jetson Nano runs the AI model for vehicle detection and traffic analysis. Third is the output layer, where signal timing is controlled dynamically and traffic data is displayed in a monitoring dashboard. Move to next slide. Here, this diagram shows the workflow of our system. First, the system starts with an IP camera installed at the traffic intersection. The camera continuously captures live traffic video and stream it to the edge device using the RTSP protocol, which means the real-time streaming protocol. It gives the current movement to the cameras. Next, frame extractions. This RTSP video stream is received by the edge device. From this stream, individual frames are extracted from processing. Next, pre-processing. Before feeding the frame into the AI model, pre-processing is performed. It includes resizing, normalization, and region of interest selection to reduce computational load and improve detection efficiency. Then our AI model YOLO V8 inference. The pre-processed frame is then passed into the model running on the edge device. The model detects vehicles such as cars, buses, and ambulances. It uses a deep learning algorithm. It generates bounding boxes and classification outputs for each detected vehicle. And then it counts the vehicles. Congestion analyzer gives the calculated based on lane capacity and current vehicle density. This score determines whether the traffic is low, medium, or high. And finally, the dynamic timing algorithm. Based on the congestion score, the dynamic timing algorithm calculates the green signal duration. The signal time increase if congestion is high and decrease if traffic is low. If an emergency vehicle like ambulance is detected, the system immediately prioritizes that lane. And finally, the traffic signal controller. The final decision is sent to the traffic signal controller using industrial communication protocols like Modbus RTU. Move to next slide. My teammate will handle.
Good afternoon, everyone. For this idea, we selected YOLO V8 Nano as our deduction model because it provides high accuracy and fast inference speed. The model is deployed using ONNX or TensorFlow Lite format. It is lightweight and suitable for the edge devices with limited computational power. It takes a video frame as input and produces vehicle classification and count as output. Next, please. Then the optimization techniques to ensure the real-time performance, we apply model optimization techniques such as quantization and resolution reduction. The system processes frames in parallel using multi-threading. This helps us achieve inference time under 1 second, satisfying the real-time constraint. Next, please. Then the constraint adherence. Our system strictly follows the given constraints. It performs the real-time inference in less than 1 second per frame. Vehicle detection accuracy is maintained while optimizing the resource usage. All processing is done locally on the edge device without using the cloud. Next, please. The resource usage. The system is designed to operate efficiently. CPU usage is optimized using lightweight models. Storage requirement is minimal since the model size is small. Memory usage is controlled through model compression. Power consumption remains low, making it suitable for real-world deployment. Next, my teammate will continue.
Next slide, please. Here, what makes us unique? Our system is fully edge-based, meaning it does not require internet connectivity. It includes emergency vehicle detection and immediate priority switching. Signal timing is dynamically adjusted using AI-based congestion analysis. Additionally, the system can generate traffic density heat maps and maintain the data logs for smart city analytics. Move to next slide. Here, our plan of implementation. Our implementation is planned in 4 stages. Week 1 involves data collection and model setup. Week 2 focuses on model training and optimization. Week 3 includes deployment on the edge device. Week 4 is dedicated to testing and validation. The system is practical since it uses existing CCTV infrastructure, we face challenges like nighttime detection and weather conditions are handled using low light training data and image pre-processing techniques. Next, can you share the demo video?
Go on, please.
Play the video. So this demo shows how our HAA system captures live traffic and detects vehicles in real time and calculates congestion levels and dynamically adjusts signal timing. And I'm already said the system uses a camera to monitor traffic at an intersection. The camera sends live video to an edge device. We use a AI model YOLO V8. It detects and counts vehicles like cars, buses, and bikes in real time. Based on the number of vehicles in each lane, the system calculates the congestion score. If one lane has more vehicles, the system increases the green signal time for that lane. The final timing command is sent to the traffic signal controller, which changes the light accordingly. I hope this demo video is more understand to you. And next, move to next. To conclude, we developed a smart and adaptive traffic system using AI. The system reduces congestion, decreases waiting time, lowers pollution, improved emergency response, and our future plans integration with smart cities systems, multi-intersection coordination, and AI-based traffic predictions. Thank you, sir. Any query?
Yeah. See, I want to know that in a single signal, how many camera requirements we have?
Sir, we have four roads, we need at least
Okay.
two cameras, sir. If we have only a single way roads, that we need two cameras, sir.
See, actually, we are placing the signals for a four-way road, right?
Yes, sir.
Four-way or two-way only. For a single way, we no need any signal at all. They are going directly. Right.
For four way
Uh,
only, we need this, sir.
okay. What is the requirement of the project?
Our IP
Hardware
cameras,
and
sir.
software.
IP cameras and our AI model YOLO V8, and then RTSP, sir, for collecting the real time video. That's it, sir.
What is meant by smart signal?
Smart signals means, sir, a traditional signal has a fixed timing only, sir. Even when the road is free, it has only 60 seconds. But smart signal optimizes the dynamic environments and change the timing, sir.
Okay. How you are going to find the vehicle density?
So using our YOLO V8 model, it detects the object, sir.
Okay. How you are going to train the things?
Sorry, sir. Sound.
So how we are going to train the model for the things what we are going to find?
Sir, with the help of deep learning, we train the model like giving the inputs, sir. Every vehicle's images and already historical traffic data. With this, we train the model, sir.
Okay. See, actually, in this we have a drawback, right? So if there is an ambulance or something is coming in a single way, right? So other way there was a huge traffic. So which one we have given first priority?
So for emergency, we give a priority, sir.
So how you are going to model this?
Sir, we already give input as a ambulance images, sir, and we predict the free routes. If the ambulance is entering, we open that lane only, sir, immediately.
Okay. 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 What is YOLO?
Thank you, sir. So
Okay. Okay. Thank.
you
Okay. Thank you.
okay, sir.
Okay. Okay. Go to the next slide.
Thank you, Twin Stars. Up next, bringing the technical edge, Team Codex, Nurul, Safinas, and Tanushree. The floor is yours.
Good evening, everyone. Wait a minute. My teammates show the screen. Good evening, everyone. We are from the Department of Information Technology, first years. Myself, Dhanushri, and
I'm Nurul Shafnas. Today, we are going to present our project on medical waste segregation system using Edge AI. First, I will explain the introduction and basic detail of the project. After that, my teammate will explain the remaining parts. This project, this project is about automated medical waste segregation system using Edge AI technology. The main aim to improve the hospital safety and waste management. Let's move the introduction. Medical waste are produced daily in hospital and clinics. If waste is not separated properly, it can spread infection and cause pollution. It can also be dangerous for workers. So, proper waste segregation is very important. Next slide. Problem statement. Currently, many hospitals separate the waste manually. This can cause human errors. Workers may touch the harmful waste. Sometimes waste types are mixed together. Some clinical face this problem more. So we need an automatic solution. Next slide. Next slide.
The screen is not visible.
wait a minute, sir.
The screen is visible.
Yeah.
Problem statement.
Which slide?
Currently, many hospitals separate the waste manually. This can cause human errors. Workers may touch harmful waste. Sometimes waste types are mixed together. Small clinical face this problem more. So we need an solution. Next slide. objective of this project. The main objective of this project to build an automatic waste segregation system. We use Edge AI to identify waste type. This reduce human contact, improve safety and accuracy. Next slide, please. What is Edge AI? Edge AI means artificial intelligence running on local device. It does not need internet for all the time. It processes the data inside the device. It makes the system faster and more accuracy. Next slide, please. Categories of waste. The system identifies different type of waste such as sharp, infection, recyclable and general waste. After identification, each waste goes into a separate bin. Next slide. Our medical waste segregation system works step by step. First, medical waste is placed on this conveyor belt. Then the camera take a picture of the waste. Image goes to the Edge AI device. Then AI model analyze the image and identify the type of waste. After classification, the controller send a signal to the motor. The motor move the waste into a correct bin automatically. All this happen inside the device without using internet. Now, I will hand over the presentation to my teammate. She will explain the remaining parts.
Good evening, everyone. I will explain the remaining parts. Next slide, please. Technology used. A camera module is used to capture waste images. Sensors and a conveyor motor help move the waste. An edge device or microcontroller process the data locally. We use Python, OpenCV, and TensorFlow like software for programming. Next slide, please. Next slide, please. System architecture. First is the input section, which include waste and camera. Next is the processing unit, which is include AI device. After that comes the classification model that identifies the waste types. The motor and the control system waste to the correct bin. Finally, the display system shows the result. Next slide. Constraint of offline operations. The AI mode is stored inside the local device. All waste images are processed locally. No data is sent to the cloud, so medical information stays secure. This makes the system faster, safer, and suitable for small clinics. Next slide, please. Advantages of the system. It improves accuracy in waste separation. It saves time and reduces manual work. The system works without internet. It also helps hospital follow biomedical waste rules. Next slide, please. Our expected results. Human handling of waste will be reduced. Waste management will become safer and faster. Hospitals will have a cleaner and safer environment. Finally, we move to the conclusion. Next slide. It improves safety and reduces human error. It protects healthcare of workers and the environment. The system helps proper medical waste management. Thank you all for listening. Any queries?
Yeah, how you are going to reduce the human interaction?
Well, sir, using the Edge AI, sir.
Using the GA, okay. So what is the requirement of your project?
Sir, camera module, Edge AI sensor, motor and pin, sir.
Okay, what is the AI device you are going to use for this?
Edge AI, sir.
Any device name you know that?
Um, YOLO.
YOLO is algorithm.
Sorry, sir.
Okay. Okay, YOLO is not a device. Okay.
Jedson Nano, sir.
Okay. Okay, why we are going for a Jetson Nano? Why not Raspberry Pi?
Sir, AGI computing, sir.
Okay. Where we are going to implement the things here?
Sir.
Is it enough? Where we are going to implement this? These things and
Medical
projects.
segregation, sir.
You are going to use this in a medical waste, right?
Yes, sir.
Biomedical waste or medical waste?
Medical waste management, sir.
Okay, who is going to segregate it? Our device or see why it is why we are not doing this before that? Before can we implement this before we are going to drop the uh, garbages or anything? Before that, can we do the things? Is this possible with your project? Can I get the alarm? Where we are giving the wrong waste and wrong bin. When we are getting alert or not, like the way can we implement the project?
I
Is
did
this
not
possible?
understand your question, sir.
See, actually, I want to know that. See, you told that after the after the waste, okay, after the waste, we are started segregating it, right? So there was lots of manual. Again, we are doing the manual segregation by a human only, right? So why we can't do the same thing before it start? Is that any sensors or any cameras which is giving alert before you putting the waste in a wrong bin? Is this possible with your project? Have you understand?
I can't, sir. She will explain this, sir.
Okay, so okay, we will go. Okay, thank you. We will go for next. Thank you.
Thank you, Tanushree. Thank you, Nurul. Thank you, sir. And next team is up next, bringing the technical edge. Fahimida, the team name is Code Pair. The spotlight is yours. Take us through solution. Fahimida, are you there? Fahimida.
Can you please present my PPT?
Yeah, please.
Good afternoon, sir. Today I am present Edge Computer Basic H HAA Basic Medical Waste Segregation and Classification System. This project focus on the improving a biomedical waste and management using HAA artificial intelligence. Next slide. In hospital and small clinic, the medical waste often is segregation manually. The improving a segregation leading to serious problems such as infection spreading, environment uncovering, and non-compiling and with the biomedical waste regularly. The healthcare working are directly exposing to the hazarding material like a sharp and infectious waste and pharmaceutical waste. The main challenge are human error, classification, leak of automatical and increasing and exposing risk. So there is a need for automatical, accurate and safe system. Next slide. Objectives.
The first to classification to at least four categories of waste: shop, infection, pharmacy, and general waste. Achieving the more than 85% of classification accuracy. Third, to reducing a human contact with materials, and the final to ensuring a real-time processing using a HAA without depending on the cloud. Next slide. Next slide. The purpose solution. This do the solution of the we purpose near HAA power automatical waste segregation system. The system using a camera to capture the waste image. The image is processed to local of the H device using a training AA mode. The basic on classification result, the system automatically direct the waste into the correct bin using a motor machine. Since the process happen locally, ensuring a better data privacy. Next slide. Next slide. I'm using this diagram basing on AI generation. This system architecture camera capture the image of the waste placed on the contact belt. The capture the image to sending to HAA device such as a Raspberry Pi and a Geno Nano. The AI classification model process the image and identification waste category, shock, infection, pharmaceutical, general waste. The basic on the motor control activity contour machine and directly the waste into the correct color code bin. The entire process happened locally on the edge device, ensuring the real-time perform and reducing a human contact. Next slide. Working machines. When the waste is placing on contour belt, the camera capture the AI model analyzes the figure of the texture object structure. Within the less than of 1 second, the model predicts the categories and the sensor motor rotating or directly the waste into approximately bin. The reducing manually handling a signification. Next slide. The AI model selection. We selecting a lightweight deep learning model such as the Leonard Tiny. These models are suitable for the edge device because they require less computing power with the willing a manually good accuracy. This model is training on the label one of the four categories: shock, infection, and pharmacy and general waste. Next slide. The automation and the edge deployment. To improving performance, we applying automation technique like quantity and curing. The quantization reducing a model size, the converting a 2-bit value into the 8-bit value. The reducing a memory usage, the spreading inference time. The model is deployment using a which is allowing effectively executing on the edge device within the cloud dependent. Next slide. Evaluation criteria. Once evaluation basing on measuring the performance, first the classification accuracy. One target is more than 85% and the prototype testing achievement around the 88%. Second, the real-time performance, the inference time is less than 1 seconds. Third, the system is significant, reducing a direct human contact. Fourth, the regular complaint wasting segregation aligned with the biomedical waste management standing. Next slide. We ensuring the given the all the strengths are satisfied. This system classification at least the fourth categories is achieved the more than 85% accuracy. The process is performed the locally on the device each device is operating in real time. Most importantly, is reducing a human exposing the automatic. Next slide. Resource usage and implementation. The system using a modulating CPU resource around a 200 to 300 MB memory. Due to the model remaining lower 100 MB. The implementation can be completing within the 4 week. The 2 week for the dataset training and 1 week for the automation and 1 week for the hardware integration. It is a practice and cost effective for the small clinic. Next slide. Conclusion. Own HAA basing medical waste segregation system providing a accurating classification, real-time processing, reducing infection risk, and regular complaint. This system contribute to safe healthcare environment and improving a biomedical waste management. Thank you.
Okay. Okay, can I have some questions? Okay, how does we reduce the human errors?
We
The HIA is more accurate than human.
HIA using without the internet because without the internet we can using a HIA to basic medical waste segregation.
Okay, however, system is better than the manual segregation.
Sir, repeat the question.
So how your system better than the manual segregation? Is this better than the manual segregation? Why we are
Yes,
going
sir.
for the
Yes, sir.
automated? Why we have to automate this?
Because when a human touch things, um, in something like immediately. So we using a machine. So yeah, it can avoiding infections and short things and something like that, sir.
Okay. How you are going to implement, then how you are going to maintain this?
Sir, we wastage convert camera. Sir, repeat the question.
Yeah. How you are going to implement the things? How you are going to implement the things, and how you are going to maintain this for a year or how many years we can maintain it? So can you please give the view?
If, mm,
So how you are going to implement the things in real time? Is this possible?
yes, sir. This is possible because um, in future, we aim to improving accurate and integrating robot
Okay, okay,
automatic.
okay,
We
okay,
expand,
okay. Leave it. Any existing system before that we have.
sir.
So what I want to know that any existing system which is doing automated segregation, or this is the first we are going to do.
Already exists, sir.
How they are doing these things without agent.
Is it like
So correct.
uh, without
Okay,
AAs
okay,
is
okay.
exit, sir? We using AA manual. The
Okay,
exit
okay,
system is
okay.
a manual bio-waste segregation system, sir, where the healthcare working slotting wasting into the color code bin without any automatics.
Okay, okay. Thank you so much.
Thank you, sir.
Thank you, Fahumita. Now presenting the dynamic strategy. Team Dynamic Dio, Vinoda and Mohana Priya. Let's dive into your solution.
Yes, thank you. Can you share a slide?
Yeah, please.
Yeah. Uh, I'm Vinoda. My teammate is Mohana Priya. We are coming from CSBS third year. Hi everyone. Today we are presenting our project Safe Step Age A Fall Detection System. Developed for the problem statement 1. Our system focuses on improving elderly safety using Edge AI technology. We aim to create a smart, reliable, and privacy focused fall detection solution that works even without continuous internet access. Uh, Next slide. Okay, let me start by explaining the problem. Elderly people who live alone are at a high risk of accidental falls. When a fall happens, delays in getting medical help can lead to serious injuries, long term complications, or even death. Many existing systems rely heavily on cloud monitoring and continuous internet connection. If the internet fails, the system fails. This problem is important because faster emergency responses can save lives. It reduces the hospital complications and helps senior citizens maintain both independence and dignity. The main challenges are detecting faults accurately in real time, making the system work without continuous internet, and protecting the user's privacy. Next slide. To solve this problem, we proposed an Edge AI based wearable fall detection device. Our system processes sensor data directly on the device itself instead of sending it to the cloud. When a fall is detected using our AI model, the device instantly sends the SMS or call alert to the caregiver. The key features of our solution are real-time fault detection, offline functionality, instant emergency alert system. This ensures reliability, speed, and privacy. Next slide. Okay, now let's look at the system architecture. The workflow is simple. The input is going to the processing, and the process the data is going to the output. For input, we use an accelerometer and gyroscope sensor to collect motion data. For processing, we use an edge device such as a Raspberry Pi or ESP32, where the AI model runs locally. For output, the system sends an SMS alert, mobile notification, or activates a buzzer for emergency response. This simple but efficient architecture ensures fast and independent operations. Next slide, please. For fall detection, we selected a lightweight LSTM based model. We choose this model because LSTM works very well with time series data like acceleration and rotation signals. It is lightweight, making it suitable for edge devices with limited resources. The model size is less than 5 MB after compression. It takes sensor data as input and gives a clear output. This is the data is full or not full. This ensures high accuracy while maintaining the efficiency. Next slide will be taken by Mohana Priya.
Optimization technique. To make the model suitable for edge development, we applied optimization technique. We used 8-bit quantizations, which reduce model size and improve speeds. We also applied model tuning to remove unnecessary parameter. For development, we use TensorFlow Lite, which is designed specifically for low power edge devices. This optimization reduces more usage, improves speed, and lower power consumption. Next slide, please. Next slide. Now, let me explain how we satisfied each constraint. First, the system must operate locally using Edge AI. We ensure there is no cloud dependency. The AI model runs completely on the device using TensorFlow Lite. Second, it must work without continuous internet. Our system processes data locally and sends alert via a GSM model, so it do not depend on Wi-Fi. Third, it must ensure user privacy. We do not use an camera or cloud storage. Only sensor data is processed locally and only an alert message is transmitted. Fourth, a real-time detection is required. Our lightweight AI model ensures low latency and immediate alerts. Next slide. Resource usage. Now let's discuss resource usage. The CPU usage is around 30% because we use a lightweight model. Memory usage is approximately 50 MB due to model quantizations. Storage requirement is about 5 MB because of model compressions. Power consumption is between 3 to 5 watts, making it switchable for low power microcontrollers and wearable devices. This shows that our solution is efficient and practical. Next slide, please. What make us unique? Um, what make our solution unique? First, it provides fully offline fall detection. Second, it follows a privacy first approach. We do not use any cameras, which makes users feel more secure. Third, it is low cost and wearable, making it accessible to many elderly users. We also added extra features such as a panic button for manual alert, battery level monitoring, automatic emergency call options. These features enhance reliability and user safety. Next slide. Implementation implementation plan. Our implementation timeline is structured over 6 weeks. Week 1 and week 2, hardware setup. Week 3 and week 4, model training and optimization. Week 5 and week 6, testing and deployment. Is it practical? Yes. We use affordable component and the system can be implemented in real homes. Some challenges include false direct deductions and battery life issues. To solve this, we plan to improve data set training and apply power optimization techniques. Next slide.
Once again, Anjuta, please mute.
அஞ்சுதா அஞ்சுதா இங்க வாயா இங்க வந்து பாரு லேப்டாப்பா என்னமோ அஞ்சுதானே கூப்பிடுறாங்க
Okay, conclusion. Safe Step provide real-time, private, and offline fall detection using Edge AI. It benefits elderly people living alone by reducing medical response time. Most importantly, it enhances safety while maintaining independence. In the future, we plan to add heart rate monitoring, integrate a mobile app, and collaborate with the government healthcare program. Next slide. Thank you.
Okay. Okay, okay. What type of sensors we are using here?
Accelerometer and gyroscope sensors, sir. Sir?
System have a wearable camera. Is the system has wearable camera or how we
No,
are
sir, no
going
cameras
to?
used.
Okay. What is the algorithm we are using?
Algorithm LSTM model, the long short term memory AI model used to analyze the data and the prediction data.
Oh, why we are using Edge instead of cloud processor?
In many situations, Wi-Fi is not available. There is a slow networks. So we use offline. We can more reliable.
Okay, if the system is work offline,
Yes, sir.
we no need any internet, right?
Yes, sir.
Okay, what are the hardware device we are using?
Hardware devices, the Raspberry Pi, the
Okay.
sensors.
Okay, how we are getting the alert and how we are going to do the precautions and all, or after that we are,
Uh,
we are,
we
we are
have three methods. First one is SMS based. The detection is fault. The caregiver have a notification, and another thing is a buzzer based. The buzzer is alarm, so the nearest people can have alert.
okay.
Yes, sir.
I want to know that how frequent you are seeing your messages. So I'm
What,
asking
sir?
you. I'm
Yes, sir.
asking you how frequent you are checking your SMS.
Um, Sir, emergency calls we can do. We can
Because
attend.
I want to know that if the SMS is working here, it is workout. Because we
Sir,
in the
SMS
emergency
or
situation.
call. Both are working, sir.
Okay. Okay, any buzzer, what are the things? Actually, I want to know that if it is an emergency, we need an emergency call, right?
Yes,
Like,
sir.
like alert should be a call or alert should be immediate something.
Yes, sir.
Some alarms are. Okay, what we are going to implement?
What, sir?
What we are going to implement?
When, sir? I can get.
Actually, we are going to predict before fall or
After the fall, the emergency call will going to the caregivers.
so after the fall only, right?
Yes, sir.
Okay, okay, thank you.
Thank you, sir.
Thank you, Vinada.
Okay.
Next up, ready to power through their constraint. Team Twin
How many?
Harini and
Still, how many
Harini
teams
and
are there?
Ritika. Two teams, sir.
Okay. Okay.
For your idea. Harini, are you there?
Can you share the slide, please?
Yes.
Okay, good evening, everyone. So, we are Team Twintech, and I'm Harini and my team member Ritika. So, today we are presenting our solution for smart traffic signal optimization. So, our project, a smart traffic signal optimization, it is using Edge AI and focuses on building a low cost, intelligent, and fully dynamically based on real time vehicle activity. So can you share the next slide, please? Okay, today the major problem if you take is mainly the traffic. So currently most traffic signals operate using fixed time intervals. So this means every lane
People
receives
gives
green time regardless of the number of vehicles waiting. So for example, if you take even if one lane has 30 vehicles and another has only 3 vehicles, both get the same signal duration. So this results in inefficient traffic flow. So what this causes? This will cause traffic congestion, fuel wastage, and increased air pollutions and delay for emergency vehicles. So the main challenge why we are designing this system is that to detect the vehicles in real time and it works completely offline. So as the budget is of rupees 8,000, so this operates within that. So next slide, please.
Okay, to solve this issue, we have proposed an AGI based traffic optimizer. Instead of using the fixed timers like we are using now, our system will continuously monitor the density of the traffic on each lane. And the videos of the each lane will also be captured using a camera. It will be processed with a lightweight AI model on a Raspberry Pi. The system will count the vehicles in each lanes and calculates the density. And it will dynamically allocates the green light if it sends more density in that lane. It also prioritizes the emergency vehicles. Like if an ambulance is detected in one lane, the system will automatically change the signal into the green light and it will let the ambulance to pass. Next slide, please.
So here is the system architecture. So our system architecture mainly consists of three main layers, that is input layer, processing layer, and the decision engine on output layer. It is the combined one. So in the input layer, a basic CCTV camera will capture the live traffic footage, and in the processing layer, the Raspberry Pi that is integrated with the AI model. So in this system we are using YOLO V5 nano model. So it will integrate with the AI model and runs it. So in the decision and output layer, it is based on a vehicle density, and a signal timing algorithm will calculate the optimal green time. So that the relay module then it will adjust the traffic lights accordingly. So since all processing happens locally on the edge devices, there is no delay due to the internet connectivity. So this whole system is going to work in offline. Next slide.
Okay, we have selected YOLO V5 Nano as a object detection model. YOLO stands for you only look once, which means the model look at the image only one time and process it. This makes it extremely fast compared to the traditional detection methods we are using now. The nano version is specifically designed for low power devices. Why we use nano YOLO V5 Nano? Because the system of the model is small. Sorry, the size of the model is small. The model can detect objects quickly. It gives good accuracy for vehicle detection and it is suitable for Raspberry Pi. The model takes the images as the input and detects vehicle by drawing boundary boxes around them. And it also classifies their type like it is normal vehicle or the emergency vehicles. Using this information, we count the vehicles and the traffic density to adjust the signal timing dynamically. Next slide, please.
Okay, this then optimization techniques. To ensure smooth operation on a low cost hardware, we have applied several optimization here. So first we used int8, that is integer 8 quantization. So it will reduce the model size and increase the inference speed. Because the Raspberry Pi we use, it is of high voltage. So this int8 quantization will reduce it. And then second, we have implemented frame skipping. We'll process only one frame every few seconds. So this will reduce the CPU load without the model into TensorFlow Lite format. So which is optimized. It will allow the system to run efficiently.
Next slide, please. Then next slide. Okay, then I'll be continuing with the constraint adherence. Our solution follows all the given constraints. To meet the budget constraint, we have used a low cost Raspberry Pi and a basic camera and a relay module, keeping the total cost within 8,000 per intersection. For the no cloud constraints, all processing is done locally on device. So the system works offline without any internet cloud server. For the low hardware constraint, we selected the lightweight AM low V5 nano and optimization techniques to ensure smooth and efficient performance.
Have you completed?
No, sir.
Okay. See, what's our motto actually? What is actually we are going to do? What is the problem? What is the solution? Two steps. Can you hear me?
Yes, sir. The
What is the
problem
real
is
real world? Yeah.
the problem is in today's world there is more traffic and there is a fixed time for each intervals. So it will take much time for the traffic to get clear, or otherwise the ambulance will get delayed to reach the hospital. So our solution is to propose an edge AI based traffic optimizer. So instead of using the fixed timers, we will continuously monitor the traffic density, and mm, we will dynamically change the traffic light into green if we detects more traffic in one lane than the other. And we will also let the ambulance be get first priority.
Okay. What all device we are using?
We are using Raspberry Pi and the basic camera.
Is the basic camera is enough to capture the high HD images? Is this possible?
Mm,
If the cost must be less than 8,000, we can use only the basic camera, sir.
Okay, what is the price of Raspberry Pi?
And there is also low cost Raspberry Pi that is within 3,000, sir. And we are using that.
Okay. How we are going to find the vehicle density, and how what is the language we are using? What is the coding we are going to develop? In which platform you are going to start it?
We will find the density by um, by capturing the images or videos of the lanes, and we will pre-process and
So, what is the capacity of the Raspberry Pi? Is that extendable, or if your images are filled? Okay, so it will take more time to process. Then it will be collapse the traffic signal, right?
sir, I
If the
can't
loading
understand.
time is delayed, if the loading time is delayed or finding time is delayed, so it will overall our traffic signal is collapsed, na?
Yes, sir. For that only it will process the image then and there while getting the informations from the traffic lane.
So how we are going to apply the same in a real time? Because the thing is that our motto is great, but is this possible to implement in a real time? If it is not working in a real time, what going to happen? So what is the disadvantages we have in a project that we have to debug the things? Okay, thank you,
Um,
thank you.
yes.
Okay,
Thank you, sir.
okay, Dharani, we are go. Sumit, how many them?
Miss Harini, last but certainly not least, bringing their unique vision to the age. Team Spiritual Lights, Shakti and Jayasurya, we are excited to see innovation through your lens. The spotlight is yours. Shakti, are you there?
Yeah, please share the slide. Hello,
Yeah, you
voice is
can.
audible.
Is it possible? You can proceed.
Please share the slide.
Screen is visible.
No,
No, no,
loading.
no.
The screen is visible.
It's loading.
Yeah, it's still loading.
Sorry guys, wait for a few minutes. I will share the screen.
Yeah, okay.
Screen is visible, sir.
Yeah, yeah, please go ahead.
Sir, I am start.
We can start now. It's visible.
Yes, sir. Good evening, respected judges. I am Jaisurya. My team is Shakti. We are spiritual teams. Today we are presenting our ideas, safe step and edge AI based fall detections and alert system designed for elder peoples. Change the slide. Problem statements. Many many senior citizens live alone and a high risk of falling. For example, if an elder person's fall in the restrooms or kitchens, they may be no one around to notice it. Sometimes helps to arrive only after several hours. So this delay can cause severe injuries and even become life threatening. As India's elder population is increasing, provide the immediate medical assistance after a fall is very important. The main challenges are low budget hardware, then no continuous internet and maintaining privacies. Next slide. Next slide, move.
Next slide, can you change?
Okay. Proposed solution to solve this problem. We propose the safe step, a privacy focused fall detection system using Edge AI. The system is a detect a falling using cameras and optional motivation sensors to process the data locally on the Raspberry Pi and send the SMS alert to the caregiver using GSM modules. Then key features is working offlines, real-time fault detections, SMS-based alerts. Okay, next slide change. Okay, this is our system architectures. This the camera and sensor capture the data which is processed locally on the Raspberry Pi using a AI model. If a fall is detected, an alert is sent through the GSM module to the caregiver. Then no data is sent to the cloud because the user privacy is full protected. Main components is a PI camera, optional MPU 6050 sensors, processing Raspberry Pi 4s, then output is SMS alert and local buzzer alarms. Okay, move the slide. Then AI model selections. We use a mobile net or SSD, which is a lightweight and efficient object detection model. Then we selected this model because it optimized for edge device like Raspberry Pi and provides the fast and accurate results. The model is detect human postures from videos framing to identify fall events. Model detail sizes are 50 to 20 MPs. Input camera frames, video streams. Then output is a human posture directions plus bounding box. Thank you. Next slide. Next slide. Move. Change next slide. Then optimizing techniques to ensure the smooth performance on low cost hardwares. We optimize the systems. Then is mention IND8 quantizations reduced input resolution, frame skippings. These optimizations is reduce the CPU usage and improve the real-time performance. Thank you. Next slide taken by Shakti.
Constraints adherence. We carefully followed all the given constraints. For the budget constraint, we selected affordable components including Raspberry Pi and camera and GSPM module. For the no internet constraints, our system worked fully offline and sent SMS using GSM. For the privacy constraint, we do not store or upload video to the cloud, so all the data is processed locally. Move to next slide. In resource usage, our system uses around 55% of CPU during deduction, approximately 350 MB of memory, around 2 GB storage, and only 5 to 7 watts of power. This makes it energy efficient and suitable for more environments. Move to next slide. Then, what makes our solution unique is first, it is a privacy focused, and second, it works without internet, and third, it uses dual verification to reduce false alarm. Additionally, we can include a voice features where the system asks, "Are you okay?" Before sending the alert. If there is a no response is detected, then it's sent to the emergency message. Okay, move to next slide. Then implementation plan. Our implementation plan is divided into 4 weeks. So first week is a hardware setup and configuration. Then second, AI model integration and testing. In week 3, GSM alert integration. In week 4, real world testing and improvements. The system is practically because it uses affordable components and open sources tools. If lighting conditions are poor, we use a brightness adjustment. If fall alarm occurred, we use inactivity confirmation to improve the accuracy. Okay, move to next slide. Then conclusion. To conclude, safe step is a affordable, privacy friendly, and reliable fall detection system. So it provides a real-time emergency alert and potentially save lives. And our solution has been strong real-world impact, especially for elderly citizens living alone. Thank you.
Okay, I have some questions. So why we are
Yes.
going for a Raspberry Pi?
What's that?
Why we are going for a Raspberry Pi?
Because
Is
it is lightweighted and also it also have in a low cost method around 300 3500, and it is very fast to detect, so we use a Raspberry Pi.
see the memory capacity is okay for capturing continuously.
What's that?
The memory capacity, the RAM and the memory capacity of the Raspberry Pi, is that enough to capture the things?
Yes, sir. There is a 2 GB around in this Raspberry Pi for affordable price 3,500. We use some 350 MB usage for storage for this
Okay.
resource usage.
How we are going to process over the video or images?
So this is capturing by also video and images. For if it is a video, there is a no cloud storage. It use only in offline, because we use less it deduct posture reduction plus inactivity check and voice confirmation less than 2 seconds, around 85 to 92 percentage with normal lightning. It give SMS alert to send carriager.
Okay, which type of cameras we are using?
Sir, in this Raspberry Pi, we use cameras like yeah, that is mobile net SSD.
your voice is not audible.
Yes, sir.
So your voice is not audible. Okay. Now okay. You can carry on.
Sir,
Okay. What is the algorithm we are going to use to implement these tools?
uh, that is what is coming? Sir, they are mobile net SSD and fault detection logic, that is rule based algorithm, optimization technique, that is flame skipping, because inactivity detection, there is a no movement for few seconds. So body orientation analysis, that is a vertical or horizontal. For mobile network SSD, that is a object detection algorithm. We use that for human body in each every video frame. So that is a bounded box and a position of the person. So it is lightweighted and also suitable for so main AI algorithm.
Okay. Is the SMS is enough?
So also there is a SMS and call based direction for emergency situations, sir.
Okay. How you find is that emergency or
Sir,
critical?
it will confirm. It will confirm for give some second with voice detection, sir. If there is they ask if there is any detection occur, they ask, "Are you okay?" or something. The sound will be give. It will detect there is emergency or it's a
Okay.
false alarm.
Okay, which type of device of we are going to use for understanding the voice and all?
What, sir? That
Which
is
type of
a
device is
GMR
receiving the voice
model.
related?
That is global system we use for communication networks, sir. Like
Okay.
or optional sensor we can use for this power supply. These are the requirements we are using for this software hardware requirements.
Okay. Okay. Thank you. You can go
Thank you,
further.
sir.
Okay.
Thank you, sir.
So thank you for giving these opportunities.
So one small thing, Twin Tech team want to present their implementations for some technical error.
Okay. Okay. Please go ahead.
So the screen is visible, sir.
Yeah. 1 second. Yeah.
Harini, are you there?
Yes, thank you so for this opportunity.
Okay.
So our unique solution is about it is completely offline functionality and it is combined with intelligent adaptation. And traditional systems are timer based. So our system is demand based and it dynamically adjusts the signal timing using real time AI analysis. And we have also included emergency vehicle priorities direction and nighttime traffic optimization. So this makes the system smart, scalable, and future ready for smart city integration. Next slide, please, Tani. So here is the implementation plan. So here we have had a prototype here. So in the first phase, we'll focus on the AI model preparation, and we have used the YOLO V5 Nano model, and we'll train it or fine tune it for vehicle directions such as cars, bikes, buses, and trucks. So after training, we'll test the model for its accuracy and detection speed and its performance under different lightning conditions. So, as this is an hardware system, we should also look after the weather conditions. And then in the phase two, it will we will deploy the optimized model on a Raspberry Pi. So we'll connect a CCTV camera for live traffic input, and the relay module it will control the traffic signals. So as I told before, so the high voltage will be turned into a low voltage and it will be so user friendly. And in the phase 3, we'll test the system in a simulated or real intersection environment, and we'll analyze the vehicle count accuracy and signal timing performance and the CPU and memory usage and etc. And in the final phase, we'll deploy the system at a pilot intersection So we'll monitor the reduction in waiting time and traffic clearance speed and fuel savings estimations. So based on a collected data, we'll fine tune the model for better performance. Next slide, please, Tarvi. So coming to the conclusion, our Edge AI-based traffic signal system, it will provide a low-cost, efficient, and scalable solution for urban traffic conditions, and it will also reduce the waiting times, fuel consumptions, and pollutions also. And since it is operating fully offline, it will ensure reliability and low latency. And our solution is practical, affordable, and ready for real-world smart city implementation. And thank you so much, sir, for this kind opportunity. Thank you,
Okay,
everyone.
okay. Welcome.
You all participants for that insightful and well structured solution. We truly appropriate the effort and clarity you have demonstrated in design within your assigned constraint. Thank you, sir, for your thoughtful insight and constructive feedback. Your guidance truly adds value to the learning experience. As we come to the conclusion of the today's Inspiration Ideathon, I would like to sincerely appreciate every team for your confidence, creativity, and technical depth. You have to shown that innovation is not about having more resources, it is about thinking smarter within the limit. And once again, a huge round of applause to all participants for taking up this challenge and pushing your boundaries. You have truly proven that leadership behind at the edge. To formally conclude today's session, I invite Hariharasudan to deliver the vote of thanks. We now hand over the session to you.
Good afternoon, everyone. As we come to the end of Edge Under Constraints, Edge AI.
So your voice is not audible to me.
Sir, audible?
Yeah. You can carry on. See, I can't. So I can't audible.
Hariharasudan, are you there?
Okay. Today's Ideathon was truly inspiring. Each team showed creativity, technical understanding, and strong problem solving. Okay, we appreciate the effort and teamwork of each one. Okay, innovation is not about the perfection. It is about the courage and to present your ideas. So and improve them step by step. Okay, I each one of them is giving the good and keep doing the things and keep planning, keep building. Don't be afraid to experiment and fail, so because that is how the new innovations are going every day. Okay, everyone has to do the things and continue the things. All are the winners, okay, according to the things. So it is really inspiring. Everyone have a good idea and good innovations. Good. Okay, congratulations to all the participants. Thanks for all. Thank you.
sir.
Thank you, sir.
Hariharan, you can continue. I think he start. Hari, are you available?
Yes, sir.
You can start.
Okay.
I think your voice is not audible. Dharani, you can carry on and complete the things.
Sir, as we come to the end of the Edge Under Constraint AGI Ideathon competition, I take this opportunity to express my heartfelt gratitude to everyone who made this event successful. First and foremost, I sincerely thank our academic director and club convener Dr. S. Palnimurugan sir, our head of the department Dr. J. Amuda ma'am, our HOD of club coordinator Mrs. S. Akilandeshwari ma'am, and our club mentor Mr. R. Gopinath sir for their continuous support and encouragement. A special note of thanks of respected jury member Mr. Manikanda Prabhu sir for his valuable time, insightful feedback and guidance to all the participants. I also extend my appreciation to all our faculty members for this presence and support. To all the participants, thank you for your creative confidence and innovative thinking under constraint. Your idea truly reflected the spirit of the AJI. Finally, I thank the organizing team and Edzen club member for their dedication and teamwork in making this event grand success. With this, we conclude today Ideathon. Let's continue to innovate, optimize, and lead at the AJI. Thank you all.
Thank you all.
Then leave.